So this section is all about how we visualize these linear functions that we talked about last Friday. I sort of want to start off with talking about a question I had you guys do in Friday's practice. I think it was like number 21 or something, where it gave you a line, something like this. And it had various points on the line. I don't know, like Q, R, S, T. And it had you finding slopes between various points. Find the slope between Q and R, find the slope between R and S, so on and so forth. And the idea that you guys should have gotten from that question was the slopes are always the same. And that's sort of like the geometric definition of what makes a line a line. It is a figure, it is a shape where the slope or steepness is constant. It's the same no matter which 2 points you pick. So that idea is how we're going to sort of come up with an algebraic definition of a line. Because geometric definitions are great. Oh, what is a line? It is something that always goes straight. But it doesn't help us when it comes to math. It doesn't help us when it comes to calculations, computations, so on and so forth. So our goal today is to build a mathematical algebraic definition of what it means to be a line. And we're going to base it off of that geometric idea, that the slope of a line is constant. It doesn't matter which 2 points we pick. So fresh picture. Basically draw the same picture, draw a random line. It doesn't have to be in a coordinate system, but hey, since I have it, why not, right? So here's just a random line. And the idea was that I can pick any 2 points on this line and the slope will be constant. Now, if you sort of think about geometry, if I have 2 points that I can move anywhere I want, that's sort of spastic, it's sort of chaotic. I sort of need to like tack this line down somewhere. So when I pick 2 random points, say this point and this point here, we normally label it as x sub 1, comma, y sub 1, x sub 2, comma, y sub 2, and then from here we have the slope formula. M equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1 plus 2. Those subscripts, y sub 2, x sub 1, they stand for points that I specifically pick. Specifically this point here, and specifically that point there. But again, exercise number 21 from Friday's practice says it doesn't really matter which point we pick. So what I want to do is account for every single possible point on this line. And to do that mathematically, we just take away the subscripts. It doesn't matter which subscript we take away, the sub 1s or sub 2s. Since I'm a math guy, I like to go in order. Let's keep the 1s, so we're going to delete the 2s. So if you delete the subscripts of 2s, by using a random x and y, that means this point here, I'll go ahead and be fancy and I can highlight it. This point right here, that means that point can move up and down the line however we want. Uh-oh, is there an undo button? Yes, there is. So how does that change our formula, our slope formula? Well, all I have to do is take away these subscripts. And then at the very least, this equation here should now describe a line and every single point on it. It just looks pretty funky. Not many people like to think of lines as fractional equations. So what we can do is what we did back when we solved equations is let's get rid of the fraction. We're going to clear the fraction by multiplying by the LCD. Now in this case here, we only have one LCD, which is the x minus x sub 1. So I'm going to multiply both sides by x minus x sub 1s. And what that does is it sort of clears this fraction here and gives us this new equation. X minus x sub 1 m equals y minus y sub 1. Now, all I'm going to do is I'm going to pivot this equation about the equal sign. I'm just going to flip both sides just so it looks better. I like the y's to come first. So flipping this equation gives us y minus y sub 1 equals, and I'm going to use the commutative property of multiplication and move the m in front. That's legal to do. Now, that looks a bit more familiar. Notice how we built this equation. We built this equation by using one fixed point on the line, y sub 1 and x sub 1, and an arbitrary point on the line. That's your regular x's and y's. So the only real information I have about this line is the point that we fixed, x sub 1, y sub 1, and his slope. So equations of lines in this format gives you two pieces of information, a point on the line and the slope. Not surprisingly, we call this point slope form. Right. This is the fancy schmancy mathematical definition of an equation of a line in point slope form. It is an excellent form of a line if you want to pull out information from it, namely the slope and the points. It's also an excellent form of a line if we want to construct equations of lines. However, today's lesson isn't about construction. Today's lesson is about graphing, and quite honestly, sort of puny, sort of sucks when it comes to graphing, because it doesn't give us a lot of graphable information. That's why most people, when they graph a line, like to use a different variation of this equation called the slope-intercept form. If I can spell intercept. This is sort of the classic automatic response that everyone gives when someone gets asked the question, hey, what's an equation of a line? It's the classic formula you see on TV and movies. What is the equation of a line in slope-intercept form? Well, that's the y equals mx plus b form. Right. Where m, again, is the slope, and b is the y-intercept. Slope-intercept form is my go-to form if I ever want to sketch an equation of a line. And since that's the topic of today's lesson, it's probably going to be an important format. However, it sort of looks ugly. I'll admit, it's not the prettiest looking equations, and sometimes mathematics is a beauty contest. We like equations to look nice, neat, and pretty. That's where standard form comes into play. The standard form of a line is a way of writing lines where it's nice, neat, crisp. It's sort of the line you present in a presentation, but like all school presentations, it's sort of useless. Doesn't give us any information to solve or to graph, but it looks pretty. And this is the standard form of a line. ax plus by equals c, where a, b, and c are not fractions. Okay. So standard form, as the name suggests, is what you can always write lines into. It has a certain format. All the variables are on one side, all the regular numbers on the other side, and there are no fractions. If you do have fractions, you just have to clear it. So again, when it comes to graphing, y equals mx plus b form is the way to go because it gives you all the information you need to graph. For example, suppose I ask you to sketch y equals negative 2/3 x minus 1. It's in slope-intercept form because it's y equals. You can always identify slope-intercept form when it's y equals. As the name suggests, it gives us information. It gives us information about the slope. The slope is always the number in front of the variable x. Now we have to remember what slope is. It's rise over run. So this is your up and down motion over your left and right motion. Right. So I'm going to go rise 2 and run 3. But I have that pesky negative there. What does a negative do? Now, I've had teachers try to have you guys memorize rules. Oh, if it's negative, you always go down. No. If it's negative, you always go left. I don't like memorizing rules. I like to understand what's going on here. So think back to a coordinate plane. This is your standard coordinate plane. Everyone knows that this is your x-axis, this is your y-axis, yes? Everyone knows that positive x's run to the right, positive y's run up, negative x's run to the left, negative y's run to the bottom. Well, when your slope is negative, notice slope is a fraction. The only way you can get a negative fraction is if you're dividing different signs. That is to say, positive with the negative or negative with the positive. So my slope of negative 2/3 simply means your rise and run are going in opposite directions. And what do I mean by opposite? I mean one way will go positive and the other way will go negative. Does that mean you always go down? Does it mean you always go left or right? No. It just means you go opposite. So a negative slope, if I go to the right, that's positive x, that forces me to go down, negative y, opposite directions. Or if I choose to go left, negative x, that forces me to go up, positive y's. So that's all a negative slope tells you. Negative slope tells you to go in opposite directions, whereas a positive slope tells you to go in the same direction. Okay. So takes care of that. Back to our example. A y-intercept of negative 1 tells us our starting number. So to graph it, you graph the y-intercept, and then you listen to your slope. So let's go ahead and sketch this guy. Try to draw your tick marks equally, but it's not the end of the world if you can't. That's why it's just a sketch. Be grateful that you did not go to math class when I was in high school. My teacher made me break out a ruler and measure them equally, which is sort of nice, but overkill. That's why God invented graph paper. You start with your y-intercept. In this case is negative 1. So you make a point at negative 1. And then you listen to your slope. Your slope says negative 2/3, rise of 2, run of 3, and because it's negative, it simply means to go in opposite direction. So from here, it doesn't really matter. I could rise 2, 1, 2, and then run 3, but since I went up, I'm going to have to go left 3, 1, 2, 3. I can make 1 point here. Or I can go down to 1, 2, but since I went negative, that forces me to go right. 1, 2, 3. However you want to move, all you got to do is listen to your slope. Once you get about 2 or 3 points, all you got to do, break out a straight edge and connect the dots. There is our line. Easy peasy. Questions, comments, concerns? All right. Don't get confused if they switch the order around. I mean, graphing lines is not like rocket science. Actually, yeah, it sort of is. You got to plot trajectories. But it's not like super duper hard. There really is not a lot of things I can do to, quote, trick you. But one thing I can do to trick you is change the order. Suppose I ask you to sketch, and I'll use function notation this time. F of x equals 1 minus 3x. Some students freak out. Oh no, Mr. Bo, the x doesn't come first. The x is second now. It doesn't matter. As long as it's in slope-intercept form, the slope is always the number in front of the x. The y-intercept is always the regular number. Do note, when I highlighted the slope, I included the symbol as well. So in this case, my slope is negative 3, and my y-intercept is a positive 1. If it helps you, recall that slopes are always a fraction. So if the slope of negative 3 is sort of messing with your mind, just know it's 3 over 1. That tells you that your rise is 3, and your run is 1. And since your slope is negative, you just go in opposite directions. So let's sketch this guy. Draw your tick marks here. Your y-intercept is at positive 1, so that's my starting point. And then my slope of negative 3 tells me I got to rise 3, run 1 in opposite directions. So if I choose to go up 3, that means I have to go left 1. Or if I choose to go down 3, that means I have to go right 1. Doesn't matter the order, that doesn't matter the direction, as long as it's opposite. And then last thing to do is break out your straight edge and connect the dots. There is your line. Question?
So, if the slope or the thing before the axis was negative, it's always going to be down the slope?
Yeah, so that's another way to sort of check to see whether or not your line is correct or not. A negative slope will always go down to the right, whereas a positive slope will always go up to the right. Yeah. Questions, comments, concerns? What if my equation isn't in slope-intercept form? Well, we just have to do unit 1 stuff and put it in slope-intercept form. So for example, suppose I ask you to sketch 3x minus 4y equals 16. It's in standard form. It looks very pretty. No fractions. All the x's and y's are together. But it's useless when it comes to graphing. So the first thing I want to do is put in slope-intercept form. To put in slope-intercept form, we have to solve for y. So I'm going to highlight the thing that we need to solve for. I hope it makes it very clear that I need to get rid of the 3x and I need to get rid of the minus 4. Solving equations, you got to get rid of the thing that's farthest away first. So I'm going to subtract the 3x over. Drop everything that's left over. And since I want it in slope-intercept form, I'm going to write the x part first. So I'm going to write the minus 3x first, and then the positive 16 last. Then the last step to get y by itself is to divide out the negative 4. Remember that multiplication and division, you have to do it to every single term. So if I divide by negative 4 on the left, on the right-hand side, I have to divide every single term by negative 4. What that gives us is a positive y equals negative 3 over negative 4 is a positive 3/4. A positive 16 divided by negative 4 is a minus 4. Hey, it's in slope-intercept form now. We can sketch them. Okay. Can I safely assume we're okay with sketching? Okay, so I'm just going to fast forward through this. I'm not going to do the whole explanation. So let's just fast forward through this here. Make your coordinate grid. Make your tick marks. Y-intercept of 4. Slope of positive 3/4 is up 3, right 4, or down 3, left 4. Connect the dots. Ooh, that was bad. Connect the dots. And there is your line. Do a quick mental check. I know my slope is positive. It's going up and to the right, so I know I'm good. Question?
So you have the right.
Oh, shoot. It should be negative 4. Thank you for letting me know. Negative 4. You're right. I was just testing you guys. So we start at negative 4, go up 3, right 4, down 3, left 4. Yeah, you guys get the idea. Okie dokie. Last thing we need to talk about, fortunately is the last thing, are special lines. I did say every single line can be written in the slope-intercept form. That will help you to graph it. Of course, everything I tell you is a lie, because there's always exceptions to rules. There are 2 exceptions. There are 2 lines out there that do not follow the y equals mx plus b format. They are vertical and horizontal lines. Okay. In case you forgot what they meant, vertical lines are lines that go up and down, and horizontal lines are lines that go left to right. Okay. So these are vertical, these are horizontal. So all equations of lines will have 2 variables, y's and x's. Y equals mx plus b. It is very easy to identify special lines because these lines only have 1 letter. Vertical lines are always x equals a number. So vertical lines only have x's in them. Horizontal lines are always y equals a number. So let me say that again. Every single equation of lines will always have 2 variables, y and x's, y equals mx plus b, with the exception of special lines. They'll only have 1 variable. If it's x equaling a regular number, it's vertical. Y equaling a regular number, it's horizontal. And you know me, I hate memorizing things. So do you have to memorize this? No. You can sort of think about it logically. Let's think of a coordinate grid. And let's look at a vertical line, say. Do you guys have a favorite x value that's small?
7. 5.
Smaller?
3.
2. 2 is good. So you guys agree that this is x equals 2 right here. I'm bolding it, I'm dotting it. And what I'm going to do is I'm going to draw a vertical line through it. If I can aim. Okay, I'm going to freehand this. There's a vertical line, right? A squiggly vertical line. We all agree that this point that I highlighted is 2, specifically 2, 0. Let's go up 1. What's the coordinate of that point? 2, 1. Let's go up another one. 2, 2. Let's go up another one. 2, 3. Let's go down 1 here. 2, -1. Let's go down another. 2, -2. What do you guys notice about every single one of those points? They're all 2's in the x's. So that tells you the equation of this vertical line literally says every single point where the x is 2. Right. So that's how you can tell what is the equation of these special lines. Also, this is the x-axis, this is the y-axis. A perfectly vertical line only crosses one axis. What axis does it cross? The x. So the equation must be x equals. If I take a look at a horizontal line, here's x and here's y. So let's draw this horizontal line. What axis does that line cross? The y-axis. So his equation must be y equals a number. Right. Question?
So if x equals 0, would it technically cross both axes?
Very good question. So the question was, if I have an equation, x equals 0, does it technically cross both axes? And the answer is yes. As a matter of fact, the equation x equals 0 is the y-axis. And vice versa. Y equals 0 is just the x-axis.
So X equals 2, is that your answer? Is that
Yeah, so the question was x equals 2. Is that the complete equation of this vertical line? And the answer is yes. The equation of this, pretend it's perfectly vertical, line is just simply x equals 2. Yep. So special lines should be the easiest to graph. You just do a straight horizontal or a straight vertical. Okie dokie? Right. There's your quick primer on sketching lines.